Question number 7, we have to prove the diagonals of the rhombus are perpendicular. Look, we have to first draw the diagonals. These are the two diagonals which join the points AC and BD. And we have to prove that these are perpendicular over there, means they are making 90 degrees at their intersection. So for this, first of all, we have to consider triangles, and then we can say the corresponding angles are congruent, and then we can also prove that the angles are perpendicular. For this purpose, we can name this intersection as O. And now we are considering these two triangles. Let's consider the triangle 1, which is BOC, and triangle 2 as AOB. So now if we observe the triangle 1 and 2, the sides AB and BC are of same length because these are the sides of rhombus. In rhombus, all sides should have the same length. Also, we can prove that the side BO is equal to BO because this is the common side in both triangles. And also we can write the side length AO is equal to OC, and we can write the reason that BD means the diagonal cuts AC into two identical halves, means AO and OC. So in these triangles, BOC and AOB, we have proved three pairs of corresponding sides equal. Means we can write that the triangle BOC and triangle AOB are congruent. So after proving the triangle 1 and 2 as congruent triangle, I can write that the angle AOB and angle BOC should be equal because these are the corresponding angles of the congruent triangles. So AOB should be equal to angle BOC, and also these two angles are on a straight line, so their sum should be equals to 180. So I can write AOB plus angle BOC should be equals to 180. I can replace BOC with AOB because these two are equal angles. So AOB and BOC can be replaced with AOB. So if we solve, we can write 2 times angle AOB. And if we divide both sides by 2, we get the size of AOB as 90 degrees. It means that we have proved that the angle AOB is of 90 degrees, means the diagonals are perpendicular at their intersection. And as I already discussed that the size of angle AOB is equal to BOC because of the corresponding angles of the congruent triangle. So angle BOC is also 90 degrees. So it is proved that the diagonals of the rhombus are perpendicular. In part B, we have to name 2 other quadrilaterals that have perpendicular diagonals. So in the square and kite, we see the perpendicular diagonals. Like if we see the square over there, for example, if I make a square, so you can easily look that if we draw the diagonals over there, they will intersect each other at 90 degrees. And similarly in the kite, if I construct a kite and draw the diagonals, you will see that the diagonals intersect at 90 degrees. So to draw the diagonals, I will just join these opposite points, vertices. So you can see that the diagonals are crossing each other at 90 degrees. In its part 2, we can use the congruency to prove this. So in the square, again, as we like proved in case of rhombus, we can also take 2 triangles. First, we can name the sides like A, B, and C, D. We can also name the intersection as O. And we can consider the triangles 1 and 2, means DOC and BOC. So let's compare these 2 triangles. So triangle DOC and triangle BOC. So in these 2 triangles, look, there is a common side OC. OC is the common side in both triangles. That's why we can say this should be equal, common side. Similarly, DC and BC are 2 equal sides because these are the sides of square. Like all the sides of the square should be equal in length. And the third thing that we can mention is that the side length DO will be equal to the side length BO because diagonals intersect each other in the middle, means the diagonal AC divides BD in 2 equal halves. So in these 2 triangles, we have proved 3 equal pairs of corresponding sides. So it means that the triangles are congruent. So in the congruent triangles, all the corresponding angles will have the same size. So look, the angle at this point means DOC will be equal to the angle at BOC. And similarly, these two angles are on a straight line. So the sum of these two angles should be equal to 180. So we can do this process over here, means we can write that the size of angle DOC will be equal to the angle BOC, and we can give the reason that these are two corresponding angles of the congruent triangles. So as I already discussed, that the sum of these two angles should be 180 because these are on the straight line. So the sum of angle DOC and BOC should be 180. And we can replace BOC with DOC, means we can write DOC plus DOC is equal to 180. And we can write 2 times DOC equals 180. So the size of DOC should be 90 degrees over there. Because if we divide both sides by 2, we get 90 degrees. So as already it is discussed before that the size of DOC and BOC is same. So BOC will also be 90 degrees, means it is proved that the diagonals in the square intersect each other at 90 degrees, means the diagonals are perpendicular. So we can write here that so it is proved that the diagonals intersect at 90 degrees. Or we can say the diagonals are perpendicular. Similarly, if we want to prove that the diagonals in the kite are perpendicular as well, we can first name the vertices, and also we can say the intersection is O, means they intersect each other at O. And we can also consider the two triangles 1 and 2. So to prove that there is a 90 degrees over here, first we can assume that in this kite, the side length AB is equal to AD. Because this is actually what we see in actual kites, that we see these sides of equal length, and similarly the sides BC will be equal to the side DC because these are also equal in length. Now to prove that the diagonals are perpendicular, we can consider these two triangles 1 and 2. So in these two triangles, look that we are comparing these two triangles AOB and triangle AOD. So first we can write that the side length OA is common in both triangles. So we can prove, so we can write that it is the common side in both triangles. So that's why it should be equal in length. And also it is given that the side length AB is equal to the side length AD. It is given. As we can see that the diagonal AC is bisecting the side BD. So it means it divides the diagonal BD into two equal halves. So we can write that the side length BO is equal to the side length OD. And we can give the reason that AC bisects BD into two equal halves. So as we have proved the 3 pairs of corresponding sides equal, we can write that the triangles AOB is congruent to the triangle AOD. So in the congruent triangles, the corresponding angles should be equal. So we can write that the angle AOB will be equal to the angle AOD. And also these two angles are on a straight line, so their sum is again 180. So angle AOB and the sum of AOD will be equal to 180. So as AOD and AOB are equal in sizes, so we can replace AOD with AOB. So AOD will be replaced with AOB, and then we can easily prove that the angle AOB is equivalent to 90 degrees. So as the size of AOB and AOD is equal, means both angles are 90 degrees. So it is proved that the diagonals are intersecting each other at 90 degrees. Let's proceed to next question. In question number 8, it says this planter holds 10 liters of composite and find the dimensions of the similar planter that holds 80 liters of the composite. Means this time we want to increase the capacity. Means in this case, the planter will be similar, but its capacity will be increased, or its capacity should be more. So to find the dimensions of the new container, first I need to find the volume scale factor. And the volume scale factor will be the ratio of the new required capacity and the old capacity. So I will divide 80 by 10, means it's 8, means the capacity of the new container will be 8 times more than the capacity of the present container. By the way, this is the volume scale factor, and for the dimensions, we need a linear scale factor. And we know that the volume scale factor is the cube of the linear scale factor. We know the volume scale factor, that is 8. For the linear scale factor, I can take cube root on both sides, and that should be 2 over there. Means the linear scale factor is 2. Means if we want to increase the capacity by 80 liters, we need to increase the dimensions by 2 times. So the new dimension means new dimensions should be like that. 35 times 2, that will be 70, and 20 times 2 will be 40, and 16.5 times 2 will be 33. So to increase the capacity by 80 liters, we will times the dimensions, or we will increase the dimensions by 2 times to get the new capacity. In question number 9, it says two containers are similar. When full, the smaller container holds 2560 milliliters and larger container holds 5 liters. So first we can convert this liters into milliliters, because we must have same dimensions when we are taking the ratio. So its A part says the height of the smaller container is 40 centimeter. Find the height of the larger container. Means definitely when the capacity of the container will increase, the dimensions will also increase. So to get the new dimension, to get the new height, first we need linear scale factor. For the linear scale factor, first we can find the volume scale factor, because the volume of two containers is given. So let's find the volume scale factor. So volume scale factor will be the ratio of the capacity of new container versus the capacity of the old container. We can divide it, and that will be 1.953. So to get the linear scale factor, we know that the volume scale factor is always the cube of the linear scale factor. So for the linear scale factor, we'll take the cube root of volume scale factor. Then the linear scale factor will be approximately equals to 1.25. So to get the height of the new container or the larger container, we'll multiply this height, means 40, with the 1.25. So the new height will be 50 centimeters. In B part, the area of the label on the larger container is 1100 centimeters square, and we have to find the area of the label on the smaller container. So definitely we know that for the area, we need the area scale factor. So area scale factor is the square of the linear scale factor. So if we take the square of 1.25, that will be 1.5625. This area scale factor means that the area of the label of the larger container will be 1.5625 times more than the area of the label on the smaller container. So the equation will be the area of the label of larger container will be equal to 1.5625 times the area of smaller container label. As we already know the area of the label of the larger container, that is 1100 centimeters square. So for the area of the smaller label, we can divide 1100 by 1.5625, and that will be 704 centimeters square. So the area of the smaller label will be 704 centimeters square. Let's move to the next part. In question number 10, part A, we have to find the side length EF and BC. We need to observe this shape carefully, that if we see this is a triangle over here, means ABD, and you can see that if we draw a parallel line over here, means EF. EF is basically parallel to AD, so this parallel line divides the bigger triangle into two similar triangles. As we know, in similar shapes, the corresponding sides ratio should be same. So we can compare these two triangles, which are basically similar because EF is the parallel line to AD, which actually divide the larger triangle into two similar triangles. So we can compare two triangles, the triangle ABD and triangle EBF. So in these two triangles, the corresponding sides ratio should be same. So we can write that the ratio of EF and AD will be equal to the ratio of EB and AD. we have to figure out this side length. So we'll write EF as it is, and AD is 72 centimeters. By the way, I have equated the side ratio EF and AD with the two given corresponding sides, with the ratio of two given corresponding sides. So EB is 24 and AB is definitely 36 plus 24 means it's the total length, that is 60 over here. Why it is 60? Because this is the sum of 36 and 24. So let's calculate it. EF will be equals to 72 times 24 over 60, and that will be 28.8 centimeters. So we have got the corresponding side length. Now we have to also figure out the side length BC. BC is this side. So for BC, we can compare the triangles ABC and AFE. Because these two are similar triangles, because this EF also divides the triangle ABC into two similar triangles. So to find the side length BC, I will write the ratio of BC and EF, and this ratio will be equal to the ratio of two given corresponding sides. So the two given corresponding sides can be AB and AE. So BC is required and EF is found in the first part. AB is given, in total it is 60 and AE is 36. So we'll just multiply 28.8 on the other side to get this side length. So it should be 60 over 36. Let's multiply. It will be 48 centimeters. So by using the corresponding side ratios, we have found the side length BC. EF was 28.8 centimeters and BC is 48 centimeters. Now in B part, it says the area of the triangle ABD is 1950 centimeters square. So ABD is this triangle, the bigger one, and its area is 1950 centimeters square. And we have to find the area of the triangle ABC. ABC is the other triangle, this one. So as the parallel lines are giving us the similar triangles, so as these two triangles are similar because their corresponding sides ratio is same, so we can write the area scale factor first. Means first we have to find the area scale factor. So before finding the linear scale factor, I can first mention that this side length is 48 as we found in our previous part, and also the EF was 28.8. So the ratio, so for the linear scale factor, I can just take the ratio of the two corresponding given sides. So the corresponding given sides ratio will be 72 over 48, and that will be 3 over 2. This linear scale factor is basically taken from bigger to smaller sides. Means this is the ratio of the bigger side and the smaller side. So from this information, we can write that the area of the bigger triangle, means ABD, is 3 over 2 times the area of triangle ABC. As we already know the area of ABD, which is 1950, so we can divide this area by 3 over 2 to get the area of triangle ABC, and that will be 1300 centimeters square. So why actually I divided the area of ABD by 3 over 2? Because this was the ratio of the bigger side to the small side. Means the area of ABD, means bigger triangle, will be equal to 3 over 2 times the area of smaller triangle. Let's proceed to next question. In question number 11, it says the triangle PQR and PUS are both equilateral. Means PQR have same side lengths and same angle sizes, and similarly PUS also have same side lengths and same angle sizes. We have to prove that the triangle PUQ is congruent to PSR. This is the triangle PUQ is congruent to the triangle PSR. PSR is basically this triangle. So we have to prove that these two triangles are congruent. So to prove the triangles congruent, there are some rules that we can follow. Like we already have learned that if the three corresponding sides are equal, then we can say the triangles are congruent. Similarly, if the two sides and the angle between them is equal, then we can say the triangles are congruent. Also, we know that if two sides and the angle, one angle is equal, then we can say the triangles are congruent. So let's prove that which of the following rule can be used over here and to prove that the triangles are congruent. So look, in the triangle PUQ and PSR, first we will compare the triangles PUQ and triangle PSR. In these two triangles, first of all, if we take these two sides, PQ and PR, these two sides are equal in length. Why? Because these two sides are also the sides of equilateral triangle, as it is given here that the PQR and PUS are two equilateral triangles. That's why the PQ and PR should be equal in length. So we'll write the reason that these two sides are the sides of equilateral triangle. Also, if we carefully observe that the sides PU and PS are also two sides of the equilateral triangle, and these two sides are also equal. So we can say PU is equal to PS because these are also the sides of equilateral triangle. Now we cannot compare the third side, means SR, with UQ because they have no such comparison. So we can think about the angles. Let's observe over here that this angle means UPQ means UPS is the angle of equilateral triangle, means it should be of 60 degrees. And also this angle means QPR will also be 60 degrees because it is also the angle of equilateral triangle. But look that they are actually sharing this angle in common, means this angle TPS is common in both of these two triangles. So we can say that if I write down the size of UPT, so UPT should be, angle UPT should be equals to 60 minus TPS, angle TPS. And also the angle SPR is 60 minus angle TPS. So both these angles means UPT and SPR are 60 minus TPS. So both of these angles are equal in size. So as we have proved that the two pairs of the sides are equal and one pair of the angle between these two sides is equal. So that's why we can say that the triangle PUQ is congruent to the triangle PSR. Thank you.